It will come. It will come on both the device. Just you need to put OK. Today you don't have math class, na?
No, sir, I don't have.
Okay, so freely you can study little bit slowly. There is no problem. I have too much time today. It will come. It will come on both the device. Just
Sir, the echo is appearing. Echo.
You don't have math class, na?
No, sir, I don't have.
Okay, so really you can study little bit slowly. There is no problem. Okay, that audible, Sanoy?
Yes, sir, audible.
Okay, sorry, na little bit disturbance. I catch where I am. This is where is the no. Sorry. Just I went on the where I went. Do you know? I went live on YouTube, just checking that how it look. Is the screen is visible to you?
So not visible.
Not visible till now.
No visible.
Now visible. So okay, see question. A reaction A plus B giving C plus D along with the product heat is liberating, right?
Heat is liberating.
Heat is liberating means delta H should be what is negative.
Yes, sir.
Exothermic is found to have positive entropy. Delta S is going to be positive. The reaction will be, they are asking what will be the reaction, whether the possible at high temperature only, possible at low temperature, then not possible at any temperature, possible at any temperature. Now, have you heard about the Gibbs-Helmholtz equation? Gibbs-Helmholtz equation. Any
Sir,
idea about
delta
that?
G equal to del H minus T del S.
Excellent. Delta G is equal to del H minus T del S. Okay. So here they are saying, suppose the negative term is there, you consider the -1. Then temperature. Temperature, you can consider anything. Suppose I am considering this is 1 and entropy value is how much? Positive, they are saying +1. Let us see. Negative, and this will be -1 and negative, this will be -2. So what will be there?
The T del S, T into del S is there, na sir? How you are adding that one?
Del S means change. Del S is what? S2 minus S1, na? S2 minus
Yes.
S1. So -2 minus 1, I keep it to 1. What is problem?
No, sir, but here T into del S should be there, na? T is
Oh,
1.
multiply. Okay.
This should be -1, -1.
-1.
Hmm.
So that is -2. So delta G is negative means it's spontaneous, na?
Continuous.
Spontaneous. Now, this is the low temperature. I kept on low temperature. How much I consider? 1. You consider some other temperature. Delta G is equal to delta H minus T delta S. Now, temperature you consider 100 degrees Celsius. So now, this is the -1 or negative anything you can consider the value. Temperature 100. Entropy, suppose whatever you consider that is 1. So what will -100. How much is coming? 101. This is negative. So whether you are going low temperature or you are going high temperature, the value delta G is coming negative.
Yes.
So what you will do?
Option number 4.
Possible at any temperature. Are you getting this one?
Yes, sir.
Or should I tell again?
Sir, understood. Sir, we
Okay.
have to display 2 cases. The first one high temperature and second one low temperature.
Excellent.
So
Excellent. Okay. Correct. Now let us go on the next question. What is the next question? Yeah. This is the question number 7. Can you tell me this question?
Just in a process 700
Okay. Tell
joule
me.
of heat absorbed by the system, 1094 work is done by the system.
Heat absorbed, they are saying 701 joule of heat absorbed by the system.
So
Okay.
this one now we did yesterday, 701 minus 394.
Do here, solve here. Okay, good.
Yeah.
Hmm. Here will be okay. Hmm.
400, 300,
Hmm.
36, 37.
How, which formula you are using? Delta U is equal to Q plus W, na? First law of thermodynamics.
Sir, we are having two delta U, sir. First of all, we are giving 701. Second, we
Uh,
are taking 394. Whether we have to find the
394
total
joule
change.
is work done. This is the work done, na?
Work done
By
by
the
the
system.
system. That
So
means negative.
negative 394
Huh.
Q as it is. And
That means
70
first of all,
joule
sir,
of heat absorbed by the system. What will be change in internal energy? So internal energy they are asking here, right? So how much heat is absorbed, heat absorbed, that is the positive. This time should be positive. So it will be 701. Del
hmm,
U they are asking. So you can solve now. 7, 0. And
3,
here will be that is
3, 3, sir. 3 will be there.
3 will be there. 3
So
not
same
7.
answer only came now, what I did also.
Okay, how you are doing, but you are writing something different here now. Delta U is equal to U2 minus E1. But here is what is this is the work done by the system. So this is negative time. Q heat absorbed, that is positive. So 307 will come. Can you check back?
Yes, sir. So that means, sir, we have to do like this.
307 joule, that is correct answer. This is correct. If you are
Sir,
saying that
that
is also this is also correct, but what formula you are using, I don't know.
no, no, sir. First of all, we'll have to write this one. So del U equal to Q plus W. So W here given minus 397, and
Uh,
sir, and Q
hmm,
is given plus 701,
hmm,
and sir here therefore del U equal to 701
hmm,
plus it's minus 397.
hmm,
701 minus 397, you're getting here 307.
hmm. The correct one. Okay. Now I am changing this one. Going to the next question. You erase this one. Can you erase this one?
Yes, sir.
Okay, 7.8. So what the question given? The reaction of cyanamide NH2Cl. I think you will be able to solve this question.
Sir,
With
this one is not going, sir.
ah,
So this one is not going, sir.
okay. Okay, leave it, no problem. Delta U was found to be, here is the 742. You solve this one fastly. Calculate the enthalpy change of the reaction. Okay, how can you do this question? This question is delta H is equal to delta U plus delta NGRT. Based on this question, this is NGRT. So already so many things they have given. What the things they have given? Delta U was found to be this much. So delta U value you can write 742.7. This is given in the kilojoule unit, you keep in mind. Then delta Ng. What will be delta Ng here? This is liquid, we need not to consider. This is gas, this is gas. So delta Ng is equal to what will be there? Ngp minus it is going to be Ngr. Ngp is 1 plus 1, 2 minus 3 by 2. Yes, yeah, no. So it will be what? 1 by 2 will
But
come.
sir, you do this from the beginning once again, sir. I am not able to understand.
Okay. Can you read the question?
The reaction of cyanamide NH2CN with dioxygen
Hmm.
was carried out in bomb calorimeter. Delhi was found to be minus 742.7 kilojoule per mole at 298 Kelvin.
Hmm.
Calculate the enthalpy change of the reaction at 298 Kelvin.
Hmm. So what they are saying, they are the cyanamide, they are burning the cyanamide in the bomb calorimeter. Bomb calorimeter, what we do? That is we calculate the internal energy or enthalpy. So what they are saying here, the combustion reaction taking place. So this is the cyanamide, it is react with the oxygen. So it is giving N2, CO2 and H2O, right? What the
Yes.
equation we are going to use? Delta H is equal to delta U plus delta NGRT. This only gives the relationship between internal energy, enthalpy, number of mole of gas, temperature. Because they are saying calculate at this temperature. What they are saying? Calculate the enthalpy change of the reaction at 298 Kelvin.
290 Kelvin.
Huh. Last one you are saying, last equation was what like that? Delta H is equal to delta U plus P delta V. This
P
one you
delta
cannot
V.
use now.
No, sir,
Because
because the delta
uh-huh.
V and P are not given.
Okay. So first of all, delta Ng you can calculate. How can you calculate? Delta Ng is equal to number of gaseous product minus number of gaseous reactant. Yes or no?
Yes.
Liquid you need not to calculate. Liquid and solid, only the gaseous molecule. So 1 mole of N2 is there and 1 mole of CO2. So this is the 2. And what is the gaseous is there? 3 by 2 O2. So I am writing here 3 by 2 O2. So if you are solving, taking LCM 2, so it will be 4 minus 3 by 2. So it will come 1 by 2. Yes or no?
Yes, sir.
So here 1 by 2. R value what is there? 8.314. It is joule, but you need to calculate in kilojoule. So you have to divide by 1000. So it become 10 power minus 3. Temperature is 298. Any problem is there?
No, sir.
742.7. Then if you are dividing this, you can easily divide this value. That is the what is there. This 2 will be get divide. So 149 it will come. So here is 8.314 multiply by 149 divided by 1000. Can you see this one?
Yes, sir.
742.7. Then it will come positive term, maybe the positive term will come. Now you solve this one. Can you do the rounding of also you can do?
Doing, sir. 8.314 we can use 8.3, 7.43 we can do 743. Then
It is coming something 1238.78 divided by 1000. So here if you are writing 742.7 and here will be the plus, it will come 1239 you can write. You can do the round figure. So you see 742.7. This will be plus 1.239. It is going to be, Sanoy, this is the 741.46. This will be the kilojoule per mole. Is there any problem in understanding this?
no, sir.
No.
No, sir.
Okay. You write something on the screen that is creating the problem. Can I erase this one?
Yes.
Here, what you wrote, Sanoy, this is not getting erased here.
Yes, sir. Not getting, sir. I also tried.
Oh, then it gone on the screen, I think. Okay. Now it is not erasing.
So let me see, sir.
It is not getting erased. What you wrote that is coming. You erase the top one. No, not working now.
Not getting, no, not working.
Okay, let me see this one from this side. If you can, it can work. Yeah, it erased. Okay. Now we are going for the next question.
The next question 6.9. Calculate the number of kilojoule of heat necessary to raise the temperature of 60 gram of aluminum from 35 degree to 55 degree molar heat capacity of aluminum is 24 joule per mole per Kelvin inverse. So first of all, we'll have to take this temperature into Kelvin. So this delta T will be 20 Kelvin only.
Okay, delta T you are saying T2 minus T1. T2 minus T1. So
Yes, sir.
this is going to be 55 minus 35. So it will be 20 Kelvin only, whether the change in the degree or the Kelvin, that will be the same, 20.
That is the
Okay.
same.
They are talking about the molar heat capacity of aluminum they have given. Molar heat capacity means Cm. How much they have given? 24, I think, 24. Yes, na?
So 24, yes, sir.
Joule per mole Kelvin inverse. Okay, this one. Now, another thing they are asking, calculate the number of kilojoule means heat necessary to raise the temperature means Q they are asking. So what the formula you will use? Cm is equal to Q upon N delta T. Right. So
Yes.
Q is equal to N. It will be N into Cm into delta T. N is the given mass upon molar mass. Cm, that is heat capacity, they have already given how much? 24. Delta
Yes.
T is 20. Given mass is, they have given 60 gram. So here we are putting 60 gram. Molar mass is 27. Multiply by 24, multiply by 20. Now check back how much is coming. Should I do or you are going to do?
Doing it.
Okay.
$2,400 into 8.
Can you tell me what unit is going to come here? Q,
Sir, Q will be joule.
joule. So if you are converting into kilojoule, so in kilojoule, what it will be there? In kilojoule, it will be 1.067 kilojoule per mole.
So 1, 3, 2, 1, 0, no? 0 means 6. The same only coming, sir, from me also.
Okay,
8,
great,
6.
great. Can we move to the next question?
Yes, sir.
You can ask if you are facing the problem, please.
No, no, sir. Not fishing.
Okay, this is the interesting questions you can take. Check it here.
1 mole of water,
Hmm.
10 degree to ice and minus 10 degrees.
Hmm. Hmm.
So first of all, we need to find the delta T.
First
Delta
of all,
T,
you need to find delta G. Okay. Then,
delta T is 20 Kelvin, like
okay.
minus 20 Kelvin.
Did you understand the questions? Question is little bit, it is the good question, high level question. See the, calculate the enthalpy change on freezing. How much they are freezing? 1 mole water
What mole of water?
at 10 degrees C to ice at minus 10 degrees C. And three processes getting involved here. So here you see that is a 1 mole water is there. So what are the 1 mole H2O? This is what is their liquid. Yes, yeah,
Yes.
no. The calculate the freezing of 1 mole. So liquid, it is going to freeze. Okay. So it will be that is H2O. This is what the freeze. It will freeze. So water that is going to freeze. Getting.
Yes.
Now this water freezing. then this water has this become the ice. Getting?
Yes.
So here the liquid changes to ice. Then finally they are saying this ice is, suppose what degree it will be, the 0 degree. Then it is the ice is again converting ice at -10 degrees C. So total 3 process involving. So
Yes.
if you are calculating delta H, so what will be there? First one, the enthalpy of fusion is there and heat capacity is there. So you can write this step, heat capacity. Firstly, heat is getting, what will be there? Heat capacity, na? Heat capacity there, H2O liquid they are saying. This heat capacity. So H2O, I am writing CpH2O delta T, because this much of heat will absorb, na? Here is what is the Cp is equal to what is there? Q upon delta T. So Q
Yes.
is equal to Cp delta T. This one, because this all this will be there. Next one is the plus. It will be the fusion. This one, first step. Next one is what will be, you are going to add, that is heat capacity of I, Cp. This is the
Sir,
H2O.
sir, can you please explain this fusion to me once? Sir, this part is not clear in me.
No, here the temperature is heat capacity at 10 degrees C. And
Mm.
here is heat capacity is what will be there? Delta T -10 degrees C. -10 degrees C. And in between what will be happening here? That is the, see, water is fused to become what? Ice. Or the ice is fusing. Ice fused to be water, fuse into water, yes or no?
Sir, what is the meaning of fusing, sir? That is what I ask.
Fusion means that is broken down. Anything is fusing. A solid mass is there, na? Solid mass. Any solid
Mm.
mass is there. So it is going to convert into liquid.
Ach.
Okay. This is the fusing means broken down. That means that much only.
Mm.
Okay. So this all the terms, whatever the terms are there, these all the terms is going to be the negative terms. This all the terms will be the negative term. It is not given, but enthalpy of fusion is what? When you are fusing, in the fusion, in the case of the fusion, it will be the heat will released. Why the heat will release? Because it is converting, liquid is converting into ice. Okay. So here in this case, maybe the bond is formed.
Yes, sir.
So bond formation is exothermic process. So here Cp value, you write Cp value, what is there? 75.3 in the term of negative. And here temperature is there. This is the 10. Here they have said, na, liquid is what temperature? Initially they are saying 10 degrees C
10 degrees centigrade.
plus.
So
Few
273 Kelvin will not be there, sir. 283 Kelvin, or we'll just write 10 degrees Celsius only.
10 degree only, na? Because water is already at the 10 degrees C. What they are, calculate the enthalpy change on freezing of 1 mole of water at 10 degrees C to -10 degrees C.
Sir. Okay.
Okay.
Understood.
Now fusion here, how much they have given? 6.03. That much only. Yeah, all the unit are there. Here this is the kilojoule. Here it is joule. It is joule. So kilojoule means 10 power -3. This is
3.
plus. Cp here already they have given. This will be the negative term 36. Temperature is already, it will come the negative term, automatically it will become negative if you multiply by -10. Acha. If you are facing any of the confusion, you let me know. This all the process are negative process. In all the case,
Okay.
energy is going to liberate. So it is
Mm.
supposed to be the negative term. So in by the way, all the cases it all get negative. So here is, it will be 75.3. So it will be 3 will be, this will be like that. Point will be removed. Here what will be there? This is again will get added in the term of negative. If you divide how much, it will be the negative term. Fusion is also the negative term. Enthalpy of fusion means the energy will liberate. So this will term will be also negative. So what will be there if you are
Negative.
adding this one? So 6.03, I am writing 10 power minus 3 as it is. And then minus 360. I don't know how much you are going to get understood or not. This is the 3. What we can do this value? If I will solve little bit this one, little bit more, let me go back. Minus 753. Then if you are solving, this will be the negative time. 0.006. Okay, minus 360. Now you solve, you check back how much it's coming.
0.006 minus 360. So first of all, 753 minus 360 is 367,789.
Hmm.
So no.
Something it is coming.
4, 383.
And I go
380.
back.
So first of all, minus. Oh, this will be addition.
So no, here it is kilojoule given, not joule. It is kilojoule. So in spite of dividing, what we need to do? We need to multiply. I am sorry, extremely sorry. Kilojoule they have given. So kilojoule to joule means what? You have to multiply.
Multiply.
Now the answer is coming here. You check your answer also. 5645 negative term. Joule per mole.
So that means 3 terms cannot be negative. No, one should be positive then. So I think this is plus 75.3 will be there. The 753 term will be positive. So somewhere we have done a mistake in the sign.
Putting, अरे यार. Here the temperature is there, na? First term. It is, see, the.
So this one I'm talking about, this one. This one. Sir, this one must be positive, sir. Then answer will come automatically.
Achha, one thing that is the when ice is formed. So heat is absorbed or released? Heat is going to absorb.
Sir, when ice is formed, heat is going to be released.
So how can we take the positive this term? When ice will form, heat is going to released. So because here is what is converting. This is ice. Okay, what they have said in the book, you see. 6.3, and this is negative terms. Yeah, they have taken the positive only. It will be positive, Sanoy. We'll check back what is the fundamental of this one. If you are taking the positive, so it is coming, no?
Answer is coming, answer is coming. If it taken
Okay.
positive, then answer is coming.
Okay, you check back that questions. Let us move the next one because it is taking time. Okay,
Sir,
this can you solve?
previous one slide once again, sir. Just 1 minute. Sir, a bit downwards. Sir, okay.
Now, okay.
Sir, last answer I want to see, sir. Last answer for this one. Aha, yes. Done.
Mhm. Liquid. 1 mole H2O liquid. Then liquid 10 degree. Then fridge. Then ice. Process is absolutely correct. The values little bit creating problem. 6.11. Can you try this one? 6.11.
Yeah.
Or should I do?
So heat released upon formation. So you do say this type of problem I do not know how to solve.
Just now we have done one. See, enthalpy of combustion of carbon to CO2. So
Ah,
carbon is burning C and O2. So it is the
CO,
CO2 and they
CO2.
are saying 393.5. Calculate the heat release upon the formation of 35.2 gram of CO2 from the carbon dioxide. So it is very simple. It is the based on the limiting reagent type problem. See, 1 mole they have given 1 mole. 1 mole means how much? 44 gram carbon gives how much? Gives 393.5
Yes.
kilojoule per mole. Yes or no?
Yes, sir.
Because they have given per mole and 1 mole is what? 44 gram. Yes or no?
Yes.
Are you getting or not? Should I tell?
Getting.
Okay. So what will be there here? So 1 gram carbon gives how much it will give? So 393.5 divided by what? 44.
Yes.
Then they are asking 35.2 gram. Therefore, 35.2 gram carbon gives how much heat will release? That is 393.5 divided by 44 multiplied by 35.2. So you multiply this one, how much is coming? राइस क्या दाल राइस तो फिर लेट हो जाता है 10 बजे कुछ जल्दी नहीं होता है Tanu, are you solving?
Yes, sir.
393.5 multiply by 35.2. So it is coming, for me it is coming 13,851.2 divided by 44.
Hmm. So
So
let
it is
me
coming
do, I will take the answer.
314.8 kilojoule. You can check back the answer also if you want. What is this here? 314.8, correct.
So 35.77 into 818.
This is the
8.1.
answer coming, Sanoy.
Yes. So last step I am doing, so let me check once.
Okay, you take, no problem.
61. 56. 61 at 546. 3 is 24.
Hmm.
Mm, 314.776. Yes, same only.
That is okay. Round figure is okay. Understood, na?
Yes.
Okay. Now, what is there? 6.12. Try it. Or should I do?
Enthalpy of carbon, this one formation.
Hmm.
Delta RH.
Hmm.
Sir, what is the required formula for this one? Can you tell me, sir?
That is a SS law you need to apply. SS law
Yes.
only. Otherwise, see, this can be done like that. Delta H, delta RH enthalpy of reaction is equal to summation of delta H product, summation of delta H product minus summation of delta H reactant. This is the formula. So whatever the enthalpy release in the formation of product minus formation of reactant. So let us firstly you do the value. What is there? CO, CO2, N2O, N2O4. Values
Yes, sir.
are what they are? Minus 110, minus 393, plus 81, plus 9.7. This is based on enthalpy of reaction now.
Yes,
So
sir.
enthalpy of reaction is what? Sum of enthalpy of formation of product minus sum of enthalpy of formation of reactant.
Yeah,
So
sir.
what we can
Sir,
do? Are you
we
doing?
will add, sir, this one N2041 9 plus 9.7 minus 110.
Okay. Then what the answer you are getting?
So then so this one only getting, therefore del H into
Hmm.
3 del H02 del HN2O4.
Hmm. This will be the negative 3 3 ja 9, 3 9 ja 27, 3 3 ja 9 to 11. Are you doing now?
Yes, sir.
9.7. And this will be the plus, minus into minus, that is plus. So 330. Solve it and let me know how much is coming. So 81 plus 330 is the 411 minus, it will be 1179 minus 99.7. So what will be there here? Minus 1179 minus 9.7. It is coming, Sana, minus 777.7 kilojoule. This is the correct according to book also, it is correct the same.
Yes, sir. So this only coming.
Is it okay?
Yes, sir. Okay.
Coming.
Coming.
Answer came, Sana?
Yes, sir.
Next one. 6.13. Can you do? Standard enthalpy of formation is per mole. Standard enthalpy of formation. Standard enthalpy of formation. Related to what? This is the heat change. Okay, heat change in formation of 1 mole product. In formation of 1 mole product. 1 mole product. Now solve. You read the question first.
I have given N2H3H2
Hmm.
H3. There are
Hmm.
H0 minus 92.4.
Hmm.
Standard enthalpy function of H3. Yes.
Hmm.
Uh,
See how many mole of product is forming? 2 mole. So 2 mole NH3 liberate. How much each is liberating? Liberating, that is minus 92.4
92.4
kilojoule.
kilojoule.
So 1 mole, what will be there? 1 mole NH3. So what we will do? Minus 92.4 divided by 2. So it will be 2 4 ja 8. 46.2 kilojoule per mole. What is the standard enthalpy of formation of NH3, standard enthalpy is per mole. So per mole, how much will come? Minus 46.2. Are you getting this?
Yes.
Okay. Can I erase?
No, sir, writing.
Writing. Any problem? You can stop me and ask, please.
Sir, I will stop you, sir, if there is problem.
Hmm.
No. Sir, done.
Okay. Now let us move on the next question. Question number 14. Okay. Can you solve this question? Calculate the standard enthalpy of formation of CH3OH from the following data. So first of all, required reaction. Required reaction means from the standard state, we have to form the product. What is the standard state of carbon is C. What is the standard state of hydrogen is H2. What is the standard state of oxygen is O2. So you need to form what is CH3OH. How many hydrogen required? 4. 4 means 2 mole. How many oxygen required? 1. 1 means half mole O2. This is the required reaction. You do such arrangement by using these three equation so that you should get this equation, required reaction. Required reaction you need to write by
The
your own.
others will cancel.
Other will cancel. Now the first reaction you see, this is the reactant side. It should be in the product side according to reaction. So reverse equation
We'll
what?
reverse this one. Reverse this one.
Reverse equation 1. So what will be
2H2
there?
plus
Hmm.
CO2 gives
Hmm.
3 by 2O2 plus
Hmm.
CH3OH
Hmm.
plus 726
Thank you.
kilojoule per minute.
726. Okay. Second, it is required in which side? Reactant side. So it will be as it is C plus O2, CO2, and this value will be 393. Second one, H2 required in the reactant side. But
Hmm.
here you see in the required reaction, 2 mole H2 required. How many given? 1. So we need
Multiply
to
with 2.
multiply. So it will be 2H2 plus 2 by 2 means it will come O2. It will give 2H2O. This value is also going to multiply to 2 6
Yes.
are 12, 2 8 are 16, 1 17, 2 2 are 4 1 5. This is negative. Now you solve this one. When you are solving this one, automatically most of the sum will be cancel out. Like what will be CO2 and this CO2 cancel out. H2O, this cancel out. So what is left here? Carbon plus 2H2. Oxygen here you see how many are there? 2 mole. How many? 3 by 2 means 1.5. Yes, yeah, no.
Uh, yes, sir.
So 2 minus 1.5 means it is 1 by 2O2. So it will give what? CH3OH. And this is absolutely what is the required reaction. Yes, yeah, no.
Yes.
What you
Yes.
did, you added this all equation. So now you can add this all. So delta H, formation of CH3OH, you are adding that is 726 plus in bracket 393 plus in bracket 572. So plus into minus, you know very well, this is the minus will come 393 minus 572. So you will come something. You check back how much is coming. It is minus 239. 239 kilojoule per mole. Check whether you understand or not. That is the important things.
So check.
Hmm.
Sir, understood.
Okay. Now move to the next question. Are you not tired now?
No, sir.
That is great. Question number 6.15. Okay. Tell me this question.
Mm, checking.
Can I do?
Yes, sir.
Or you are going to do?
Sir, you do, sir.
Okay, good. Hmm. See what is they are saying. Calculate the enthalpy change for the following process. What is there? CCl4. It is giving what is that is carbon gas plus 4Cl and calculate the bond dissociation enthalpy. This all the terms are given. Okay. What is their vaporization they have given? Vaporization means what? CCl4 is there. This is the liquid. So it is converting into CCl4. This is the gas. How much is there? 30.5. This is vaporization, first equation. Second one you see. What is their second equation? Enthalpy of formation of CCl4. So from where you can form this one? From where this product can be formed? So from the gaseous state, the product going to form. So second state I am writing CCl4. This is the gas. It is converting into no, not this is enthalpy of formation given. So C plus 2Cl2, so CCl4. This is what the term na enthalpy of formation. F means formation. So how much is there? 135.5. This is there. Enthalpy of atomization of carbon. Enthalpy of atomization. So carbon solid is converting into carbon gas. So this is 715. Last one is there. Any other point are there? Enthalpy of atomization of Cl2. Cl2 means this is the Cl2 is there. So here we will write that is Cl2. It is converting into what? 2Cl. Atomization means converting into atom. This is the gas. This is gas. This is solid. This is gas. This is going to be gas. Here is going to be gas. Okay. And here the energy is there. How much? 242. These are there. Now enthalpy of reaction. How can you bring out the reaction? Delta RH. So product minus reactant. That is what the we have to do. That is product minus reactant. Product minus summation of enthalpy of product minus summation of enthalpy of what is going to be reactant. This is the terms we have to use. Now, what are the product side? What is the product? So product in the required reaction, what is there? Carbon is there, na? Carbon gas.
Yes, sir.
This is the required reaction. Required reaction is what? CCl4 gas is converting into C gas plus 4Cl gas. So product are there, that is what? C gas. What is the value of C gas? Can you see? This is the value of C gas. So it is the
Yes.
715. Yes or no? Yes or no?
Yes. Yes, sir.
Another product is 4Cl. 4Cl is there. So 4Cl means what? Where is the Cl? This is the 4Cl atom. This is the atom, na? Yes or no?
Yes, sir.
4Cl. So what we will do in this case, 4Cl is the product side, right? This is also product side. But here 4Cl required now. How many Cl they have given? 2. So plus we will do, but we have to multiply by how much? 2. So 482 will come. 482. 484.
Yes.
484. Why I multiply by 2? Because in the required reaction, how much is there? 4. You can see. So this is the product minus summation of what? Reactant. Reactant is what is there? Firstly, it is the liquid and then it is gas. Both states are there. So summation of what is the product, two things that is reactant Gas is there, that is okay. But liquid is also we need to use now. So here is CCl4 liquid. Liquid to gas, how much is there? 30.5. Another is there. Another terms are there. CCl4. This is also there. Gaseous state and liquid state. So this also we need to add 135.5. These things. This summation sign I am removing. That is not required. The simple is that is product and reactant we are doing. Here is the UC 715 484 minus 30.5 plus 135.5. Here enthalpy of atomization. This is product side. Okay. You check back how much is coming. So 715 plus 484 plus 135.5 minus 30.5. It is coming how much, Sanoy? This is coming 1304.
Yes, sir.
RH. 1304. Getting?
Yes, sir.
I think you are getting confused also.
No, sir, little bit I was confused, sir, but got clear. No, no. Now
Okay.
got clear.
Now, see
Sir,
the
you just
second.
keep this one. Sir, keep this one for 1 minute. Sir, let me write this one first.
Okay,
Sir,
I'll
here
give the
little
time. You see
information.
the second part. Calculate the bond enthalpy of CCl bond. Only one bond they are asking. What is? So for four bond, you see the four bond is broken now. Here see,
Yes, sir.
carbon is broken into four bond. Four bond energy releasing this one. Yes, yeah, no. So
Yes.
4, here if I will write delta H, 4 into delta H, which bond? That is 4 Cl bond. For 4 Cl bond, it is there how many? 4 CCl bond. These are there. How much is there? It is there 1304. Here you need not to write 4. This is okay. So for 4 CCl bond is the 1304. So delta H only 1 CCl bond. It will be 1304 divided by 4. So it will come 4 3 are 12, 4 2 are 8, 4 6 are 24 kilojoule per mole. Little bit tough, little bit, not much more. And bond dissociation is the endothermic process. So it will be sign will be positive because you are breaking the bond. So energy need to supply.
Yes, sir.
Check.
Sir, I'm writing down, sir.
No problem, no problem. You take your time.
Del RH.
Done.
Sir, done.
Okay, next one. Yeah. 16, question number 16. Try it. For isolated system, delta U equal to 0. Isolated system means the system where that is the neither matter nor heat is getting exchange. This is the isolate. Open system, closed system, isolated system. There are three type of system are there. So this is isolated system. T is constant. T is constant, they are saying. Once the
Yes.
temperature is constant, internal energy will also be going to be constant only. This is the isolated system. Then they are saying what will be delta S? What will be delta S? What will be delta S? See, whatever the material are there, suppose you added the two gases, okay, H2, and suppose you add the helium gas, okay. So what will be there? These two gas are going to be mixing now.
Yes, sir.
So when two gas mix, when two gas mix, randomness increase,
Yes.
randomness increase, randomness increase. Whenever you are mixing the gas, even the gas are alone, they will randomize. Gas will be in the random order. So that is
Yes.
what is randomness increase. So delta S will be what? Positive.
Delta is
Entropy.
only
Uh-huh. Uh, Actually, the what is the note is there? Entropy of universe is increasing. Entropy of universe. If you are not doing anything, universe is increasing. So whatever you are doing, the entropy is going to increase. Okay. So here the if you are mixing anything, any process is happening inside, so entropy will increase until or unless it form the product. So they are not giving any question of the product, only they are isolated system. Isolated system, you are mixing something. So entropy randomness will increase. Ge- Getting my point.
yes, sir. Sir,
Next.
keep this slide for one, sir. I will write. I will write.
No problem, no problem. When two gases mix, I wrote
Sir,
very
better if
roughly
you
here.
can dictate the answer, sir. If it come in the exam, I will write in that way only. Sir, can you dictate
When
the answer?
when two gases mix, randomness increases. When two gases mix, randomness increases.
Yes,
So
sir.
delta S will
Hmm.
be positive.
Hmm.
Entropy of universe, note is there entropy of universe is increasing. So delta
Hmm.
S is positive. This is the note. Once you
Yes.
read the solution I send you, only you spare 5 minutes and you see what the answer you are knowing and the answer which you are writing should be correct, same.
Yes, sir.
Next, you see here. Can you tell me this one? Question number. For a reaction at 298 Kelvin, 2A plus B gives C. Delta S is there 4. Delta S is there 0.2 kilojoule more. At what temperature will the reaction become spontaneous? Considering delta H and delta S are constant over the temperature range. So what we will write delta G is equal to delta H minus T delta S. This is there. At equilibrium. At equilibrium, if you talk about equilibrium, whenever equilibrium condition is there, so delta G is going to be 0. So
Yes.
0 is equal to delta H minus T delta S. So delta H is equal to T delta S. It is there. So temperature they are asking. So delta H upon delta S. So delta H value how much is there? 400 kilojoule. Kilojoule per mole. Temperature is there 0.2. 2 2 ja 4. Decimal you are removing. So multiply by 10 now. So this decimal will remove by this. So it will give that is 2000 Kelvin. 2000 Kelvin. At 2000 Kelvin, it is at equilibrium. At 2000 Kelvin at equilibrium. The system is at
Yes.
equilibrium. So if temperature increasing, temperature is more than how much? More than 2000 Kelvin, then the process is process is what is spontaneous.
Yes. So let me write down, sir. Take only. I will take only 1 minute.
Okay. Kindly you understand the concept also. You must not miss that one.
Sir, at the downward, what you have written is 0/2.
That is what the value they have given. You see the question? Delta is 0.2.
0.2.
0.2. So I multiply by 10 to remove the decimal. So with this, the decimal cancel out. And then it become what? 4,000. 4,000 by 2. So it give 2,000. So at 2,000 temperature, if temperature is at 2,000, it is equilibrium. So if you are
Yes, sir.
increasing, then it will become randomness, na? Spontaneous. Hmm.
Yes, sir. Is it done? Done.
Okay, next. See here. Question number 18. For the reaction 2Cl gas to Cl2 gas, what are the sign of delta H and delta S? See.
2Cl to Cl2.
2Cl gas to Cl2 means here is Cl atom is gaseous atom plus Cl atom is gaseous atom. So here is Cl bond formation. So bond formation is endothermic or exothermic?
Sir, bond formation is exothermic, releasing heat.
Exothermic. And if it is exothermic, so delta H will be positive or negative?
Delta H will be negative. Delta
Okay.
H will be negative.
Okay. Now, see 2 mole. Here is gas is 2 mole. Now the number of gas is 1 mole. So number of mole decreasing.
Yes, sir.
Number of mole is getting. So randomness increase or decrease?
Sir,
Randomness,
randomness is
it will decrease. Here the bond form, na, earlier it is the gas. Atoms are unstable. Atoms are there. Now it become molecule. Molecule are stable. Yes or no?
yes.
So randomness decrease. So delta S is negative. Are you getting this?
Yes.
Okay. Can I go next?
Yes.
Question number 19. What there? For the reaction 2A plus B giving 2D, delta U is this one, delta S is this one. Calculate delta G not for reaction, predict whether reaction will be spontaneous or non-spontaneous. So delta G is equal to minus 2.303 RT log Kc, or this
V
one
by
is
V.
cannot. No, this you cannot use because it will be, it should be in the relation of the H and also na delta G is equal to, this will be not, is equal to delta H naught minus T delta S naught. What temperature they have given is standard temperature. Here what they are saying somewhere, na? What is the, this one? Calculate delta G naught for the reaction, predict whether the reaction. This cannot be used, Sanoy. Temperature not the given now. How can you use this one? For the reaction 2A and nRT, that is also good. For the reaction 2A plus B giving 2D gas, 1 naught kilojoule per mole is this one. Calculate delta G naught and predict the whether reaction occurs spontaneously or not. At what temperature they did not mention now.
No, sir. Temperature dependence.
And H is also not given. Okay, this only use. This is little bit critical. It look like critical. Why? Because what is given? See the given one. Delta U is equal to given minus 10.5. Delta S is equal to given minus 44.1. So here you can use this equation. Delta H is equal to delta U plus delta NGRT. This you can use. So you can get this value delta H here. So delta H minus T delta S. Should be the question should be you read the question. Can you check the question in NCRT? Question number 19.
So for the
It should
reaction,
be it should be the some standard condition. Can you read the NCRT?
sir, one line is given.
Uh,
Yeah. Sir, for the reaction. Sir,
it
should
should
I
be the
send you
two
the
nine.
photo for this one? So this is a bit different in NCERT.
What they have given?
Sir, del H equal to, sir, given del H equal to 400. Oh, no. This one.
Question number 19 you check.
Sir, del U minus 10.5. Del U. Sir, calculate G naught for the reaction. Predict whether the reaction may occur.
Temperature.
No, sir. Nothing given.
Then you consider the standard condition. Standard. Standard condition is 25 degrees C minus 298. So here is the 10.5. Then delta Ng, you can calculate delta Ng. What will be their number of gaseous product? 2. Reactant, how much is there? 2 plus 1, that is 3. This is coming minus 1. So here I am putting minus 1. Next one, R. Here this value given kilojoule. So it will be 8.314. 10 power minus 3. Temperature you can write 298 Kelvin. Now you solve this one. Minus 10.5. And this all term will be minus 8.314 298 divided by 1000. Minus 10.5. This will give some value it is going to give. You also try to calculate, please. 8.314 multiplied by 298.
We can take that as 8.3 into 300. Will be easier.
So it is coming how much, Sana? This is 2.4775.
2.9. So
Both will get added. So
So
the
you got
negative.
775, sir. I got 249. So same only, almost.
Okay. So what will be the value? 10.5 plus 2.4775. So it is the negative term 12.9775. This is there.
So I got 12.99.
Okay, no problem. So delta G is equal to, we are plugging the value minus 12.97. U value, delta H value, then minus. Here is T298. And S value they have given, joule. Here we got the kilojoule, na? This is the
Yes.
kilojoule. And here they have given joule. This is the joule per Kelvin. So this again we have to divide by 1000. Multiply
No, sir,
by.
we can do this one as joule per Kelvin, and sir, here we will convert to joule.
That anything you can do. So here it will be minus into minus, that will be going to be plus 12.97. This will be plus. So 298 multiplied by 44. It is coming 13112 divided by 1000. So here divided by 1000. So it is minus 12.97. And here is plus 13.112. It is there. So minus 12.97. What is going to come? Here answer is coming 0.142. This is plus. Plus means that is non-spontaneous. Delta G positive means that is going to be non-spontaneous. Can you check little bit in NCRT what the answer given?
Let me check. The first time substituting this one, then check.
Here, for according to me, it is correct one. Only 1, 2, 3. Small question left, so we will finish now within 10 minutes.
Yes, sir.
You must be tired now, attending this much long time.
So it's okay. I needed this to be complete, sir.
Ha, ha,
Sir,
ha,
this
ha.
will take time, but sir, when I'm solving in front of you, that saves even more time. Then I do not have to match the answer second time.
Yeah, yeah, yeah.
This is question number 19. Says zero point 0.8 bar it is given.
What they have given in NCRT?
This is 9. Sir, this is
Question
9.
number 19.
0.164 kilojoules, not spontaneous.
No, no. Okay, here the in
Sir,
other
I
book.
think what they have done is, sir, instead of 298, they have taken 300 Kelvin.
That can be. That can be. Here
I
the value in the side book it is given 0.134. So we are approx. So this approximation will work. No problem.
So this actually will change from point to point because anybody can take any value here.
Yes, 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 yes. Now the next question you see here. Their question saying the equilibrium constant for the reaction is 10. Means Kc is equal to 10. What will be value of delta G naught? Delta G naught they are asking. R value they have given 8.314. Temperature they have given 300 Kelvin. So it is very easy. Delta G naught is equal to 2 point minus 2.303 RT log Kc. RT log Kc. So this will be minus 2.303, R value 8.314, temperature 300, log Kc, that is log 10. Log 10 value you must be knowing that is 1. Yes or no?
Sir, how okay, why Kc equal to 1?
They have given now. Equilibrium constant that is Kc, 10. So log 10 value is 1. This is the formula. I think you did not study thoroughly the thermodynamics, all the concept. So no? Hello? Are you listening? Hello? It is coming 5744.14. Okay. This will be in the joule. In the kilojoule, that is, it will be the 5.744 kilojoule. Negative, negative,
19.9 into 300. Very good.
negative means
This
this
one.
one. Check the answer.
Sir, same. 5
Okay,
minus
good.
5.744.
Okay, next one. Here you see the question number 6.21. See, what is there here? Comment on the thermodynamic stability. Okay. Along with the product, heat absorb. Along with the product, heat absorb. Positive is there, na? Heat absorb. So heat absorb means what? Heat absorb means what? More energy. Product is having more energy. Product is having more energy. Means product and energy is already there. So more energy is what? Unstable. Less stable. Less stable. Now, here is the along with product energy loss. Energy loss means no energy. That is less energy. Less energy. Because energy loss, less energy. So more stable. So which one is more stable? The down one is going to be more stable. And upper one will be less stable. Because along with the product, what is there? Energy is liberating. Energy is there. So that will be, the system will be what? System will be the unstable. But when energy is lost, suppose energy lost along with the product. So that is, it is having the less energy. Less energy means stable. Getting?
Yes.
The last question. Calculate the
Sir,
entropy
sir,
change
what is the
in,
statement that I should write, sir, that you can dictate to me? So what I should write?
see,
Um,
heat
sir,
absorb.
this one
Positive
only.
term, positive means heat absorb. Heat absorb means more energy along with product.
Sir, if
Along
I
with,
write this much, then it is okay, na?
so what? The concept is this one. So more energy along with product, and
So
more
then okay,
energy
I
is
will.
less stable. High
Yes,
energy
sir.
molecule less stable. Here is less energy along with product. Along with product. So it will be more stable. Is it okay?
Yes, sir.
You see the, I send you the answer key. You check that one once. This question, the last one. Calculate the entropy change surrounding when 1 mole H2O is formed under the standard condition. So what they are, entropy change in the surrounding, entropy of surrounding they are asking. Now, it is very important, good question. Delta S is equal to Q upon T. But here is what they have given. Delta H is equal to minus 286. This is what? Heat loss. Heat loss to surrounding. Heat loss to surrounding. Yes or no? That is surrounding temperature increase. That is surrounding temperature. What is going to be? Increases. Surrounding. And what they are asking? Entropy change in the surrounding. Surrounding they are asking. So it will be Q surrounding. So Q surrounding, in spite of taking negative term, what we need to take? You need to take positive. Why? Because water, entropy of water, they are not asking. Is called is entropy of surrounding. They are asking when 1 mole of liquid is formed. So
Hmm.
standard enthalpy condition is what? This much of energy released. This energy released is going to absorb in the surrounding. So surrounding will be positive. So positive what? 286 divided by what the temperature? Calculate the
So written minus
entropy change
36.
surrounding when 1 mole H2O form. Standard condition. What is standard condition? 298 Kelvin. 298 Kelvin.
Sir, you told it will be positive, but sir, you written minus
No, no, no.
286.
It is positive. Yeah, positive. Sorry. 298. So delta S, what will be there? Unit if you are writing kilo, joule, mole, inverse. This is there. And here is Kelvin. So if you divide this one, how much it is going to come here? Can you do? 286 divided by 298. It is coming something 0.959. It will be kilojoule, mole inverse, Kelvin inverse. Can you check the answer? Or in the joule you are calculating 959 joule, mole inverse, Kelvin inverse.
So 959.73 Joule Kelvin inverse.
That is correct. That one is coming, Sanay. Because
Sir,
here
delta
is
S unit will be sir Joule Kelvin inverse. Sir, mole inverse will not be there.
here you see here the unit of the H. So Q value they have given. In what they have given? Kilojoule per mole. So what will be there? Kilojoule per mole, it is already there. And Kelvin, it will go from the down. So kilojoule per mole per Kelvin. Here already this one also given 1 mole. So no problem if you are not writing per mole. It is automatically 1 mole because it is given is standard also. Standard means per mole.
Hmm. Yes, sir.
What will you study tomorrow?
Sir, equilibrium.
Equilibrium concept or exercise?
Sir, concepts I have only 2-3 points, sir. I will send you by today. Rest we will do exercise.
But you don't send, na? Generally, you don't send. Today also you did not send.
Sir, today you told me yesterday that today we will do the exercise. So, sir, that is why I did not send.
So equilibrium chapter you already study. Only few things you are missing now. Only few things.
Yes, sir, few 2-3 topics there are problems, sir. I will send you that today by today only.
Ajay sir, no, that one Akash portal you are log out now. I will just joining. It will give the OTP so you share me now.
So, okay, okay, sir. Hmm.
After 5 minutes, I will join with the that one tab. So here it's okay. Any problem is there till now?
No, sir, no problem.
So thermodynamics almost cover. You go to the example index or anything, whatever you want to ask from thermodynamics, you can ask. You are free to ask. So now it is your responsibility to practice this one thermodynamics, practice and ask the problem, practice and ask the doubt.
Yes,
Any
sir.
of the problem is there, practice and ask the doubts. It should be 100% clear, one chapter.
Okay, sir.
Now next one equilibrium. Equilibrium will cover 100%. Don't worry.
Okay, sir.
Okay.
So, right
Okay.
after the class only I am sending.